Welcome to another exciting computer networks class. I went to the office today and they told me I was in time code 1D. And what that says to me, the instructor, is that I have a final which has been scheduled. And my final is scheduled at 3 o'clock on Monday, May 5th. Isn't that right? It's my final. Is a final a test?
Yeah, but I thought we were doing a project.
Well, okay. Maybe the test will be that you are able to implement this project. That's your test.
So we just have to hand it in?
Well, you think you should come to the class. I believe that the term is mandatory. And what that means is it's required. See, mandatory means required. So you have to come to class and demo your stuff. Hand it in using Blackboard, but demo in class. Show us your stuff, and then you are eligible to leave. Now, having said that, I will be here early. So if you want to come early, you can demo and leave early, especially if you have other things to do during finals week, which is almost certain. Yes?
What day?
Oh, so Monday, May 5th, your exam time is 3 p.m. Got that? In this room. With me, here. Got that? All right. And now, what I would do is I will write this up by the end of the class so that we can know exactly what it is that we are to be doing. But, let me just sort of establish we all understand what it is we're supposed to do. We have, I'll call it, shall we call it an assignment? Yeah, okay, call it an assignment. So the assignment is the final assignment. And so for your final, okay, you must, M-U-S-T, show up and demo your project. I could say except in exigent circumstance, but I'm not going to write that. So if there's really some issue where you need to come earlier, like at 2 or something like that, fine. But the scheduled time is 3 p.m. May 5, Monday. And just check me to make sure I'm honest on this. May 5th is a Monday, right?
Yes.
Okay. And 3 p.m. is not conflicting with anybody's final, right? All right. If there is a conflict here, or if you're taking more than 2 finals during the day, I need to know about it.
Mine is at 2:30.
You have a final at 2:30?
No, it ends at 2:30.
Ends at 2:30. Okay. And do other people have finals that end at 2:30?
I don't know.
You don't know?
I think I have something with it.
I'm surprised because, just not to put too fine a point on it, May 5th is less than 2 weeks from now. I know it seems harsh, but I mean, the end of this semester is here. There's nothing we can do about it. So that's it, man. 2 weeks from now is May 7th, and that's a reading day. And I'm not allowed to have this due on a reading day, because that's a Wednesday, May 7th. I just assume have it on the reading day, but I can't do it. So, show up, demo your project, make sure it is submitted on time. After that, you may leave. You do not need to hang out and watch other people do their demos. If you don't want to be like in line waiting to do a demo, come early, and then you can leave early. I will be here. I will be here at 2 p.m. So if you want to come at 2, come an hour early, do your demo, get out before you're having to wait online for other people, and then you can get off and do whatever. Now comes the details. What is it you're supposed to do? Aha! I'm glad you asked me that. See, there's a general lack of curiosity. By the way, Professor, what is our final? Oh, well, you don't need to know that. That would be telling. So what I would say is, for your final, you are to implement a networked two-person what is it called? Not tic-tac-toe. Pong. Right? That's what we're doing. Pong game. That can work in, how do we call this? Real time? What is real time? Have we discussed real time? Real time. Real time. We can discuss real time. Let's think about this. Shall we get it to work on 2 machines? On a network? So 2 people can play against one another? I think that would be very fun. Please get your game to work on 2 machines. Okay, that makes it very fun.
Is it a group project?
Well, you may want to use 2 machines here in this classroom, or if you want to work with a friend to make it work, that might be okay. 2 laptops, for example, working over a wireless network. Although we have a number of wireless desktops here, you could probably have a laptop working with a wireless desktop. Presumably 2 desktops or 2 laptops, however you'd like to arrange it. What else do we need to use? Oh, use RMI to communicate, how do we call this? Pick data. Pick data is X, Y, and click, or select data, I guess. Mouse pressed, mouse released. Mouse events. How about to communicate the mouse events? That makes it, I want to say X and Y and mouse pressed and mouse released. It's mouse events. That's enough. Now, the question is whether or not you want to serialize mouse events. You may not want to. In fact, you might be much better off creating a small data structure that is serializable and contains only X, Y, and whether or not the mouse has been clicked or released or pressed. Right? So in other words, you could have a Boolean in there that says mouse released is true, and that might be sufficient. So you could be transmitting int for X and int for Y and a Boolean, and you're done. That's enough for a data structure. So you may like to XMIT a simple serializable data structure, i.e. integer x, comma y, comma semicolon Boolean mouse, or how about this? Is mouse clicked? Something like that. Or similar. Similar. Right? So in other words, you don't have to serialize a mouse event per se, but you might like to take the data that's in a mouse event and serialize that. Let me think about this a moment. Your game should be able to, how do we call this? Exmit, transmit, communicate. How about that? Communicate. Communicate the score across the network. So the score will be how many points, right, were obtained because a ball was missed or something like this. Let's see, what else do we need? Can you think of anything else we might need to make this game work? So I need the score, I need X, Y, and whether or not the mouse is clicked in order to start the game. Should we be able to restart the game? Yeah, you will need a restart. Oops. Restart command to zero out the score and begin again. Now, how would you like to implement the restart command? How about the keyboard? The keyboard. Let's see, character, and then I don't like to micromanage, but let's just sort of agree. How about quote R will restart the game and zero the score. That way you can have a new game after it's ended. You can hit R, zeroes out the score, and ball's in the center, and you can begin again. Fun, right? What else do I need to make this a fun game? Anything else? You guys are good with this? Yes, sir.
Are we to implement the graphics ourselves, or are we?
You can use, you may use or reuse any of the code supplied in class. So if you want to use JPong or whatever they're calling it, what is the name of this thing anyway? It's called RMI Pong in one case, and its subclass is JApplet, so you could use RMI Pong, or you could use Pong, or I'm not sure what you'd want to use. Probably the RMI Pong, or just Pong. So, for example, you may reuse the Pong class in the graphics package if you want. Sorry, what did you say?
I was saying we started last. I was just saying we started that last time.
Yeah, we started using it last time, so I thought you would want to use it. If, on the other hand, you said to me, oh, I can do it better, what do you know? I'd say, okay. Maybe you'd like to use Ruby on Rails.
Is there extra credit?
Is there extra credit? Yes. I give you major kudos if you write the whole thing in Perl.
Really? Come on.
Yeah. You want to write it in Perl?
No.
No, I give you a double if you write it in Fortran.
No.
So, yeah, if you want to, you can write it in VHDL and have the whole thing work on a DE2 board. I'm really psyched to see. You can have an ASIC for that, because you'll be selling thousands of these Pong games. I know Pong is very popular.
I'll write it in Ruby if there's extra credit.
Really?
Yeah, I'll attempt it. I've never written anything in Ruby.
Wait a minute. I'll attempt it.
I mean, I'll do it.
You will do it. Because if it doesn't work, it could be counted against you, despite the fact that you used heroic efforts to make it work in a language I felt was too exotic and too impractical.
Yeah, but if it works,
then you get extra credit. Absolutely. You're going to do it? Really?
Yeah, it's not that sounds fun. It's gonna be hard, but.
I think it's very hard.
Yeah.
You made your life a lot harder. It's a funny thing about you. If there was an easy way or a hard way, You found a way to do it like the hard way. What? Don't take this the wrong way. What's the matter with you? Oh, sorry. There's something fundamentally wrong. You want to do it the hard way, do it the hard way. I won't stop you. So when is this thing due? How about we make it due at 3 p.m. because that's when it's due. And that's it. Now, let me say this about lateness. It's a final, okay? The final may not be handed in late. Why? Because I need to grade it and I have to submit grades. And that's it. I mean, my grades are due. So it may not be handed in late. What else? Is there a question, Arodi? You kind of look like you're chit-chatting there.
I cleared it out.
Is there... Brian, you're good?
Yeah, no, I was asking, so I cleared it out.
Okay.
Sorry, it had nothing to do with this. I'm sorry. I'll go over those.
I'm hitting submit now. Unless someone has a question. No? No questions? Okay. Hitting submit. Ready? I have hit submit. So that's it. Final assignment. I spelt final wrong. Whatever. We can edit it, right? Maybe it isn't it. Edit. I don't know how that could have happened. There. Now I hit submit again. That's all good. So we got the final assignment. We got a due date. And that's it. Okay, you guys are done.
Yeah.
Have a nice day. Oh, you want me to give you some guidance on how to do the final? Okay. Well, I'm happy enough to do that. I've prepared a little review on mouse events. I was tempted to give you actually, you know what I was also thinking is maybe a little review on keyboard events, since there's a keyboard thing going on as well. I was going to skip the keyboard event because I figured that's not directly related to your final and therefore I won't discuss it. But since it has all of a sudden become directly related to the final, I thought I would discuss that too. So first thing I want to do is I want to tell you a little bit about keyboard events. Keyboard events are built into the java.awt event package. And so they're a part of what's known as the core Java API. This core Java API is the same API that would be available to you if you were programming on a cell phone. So if you had the Java 2 Micro Edition, which is known as J2ME, which is common for Nokia cell phones, you would still find mouse events. You'd still find AWT. You might not find swing, but you'd find, you know, frames and buttons and things like that. Mouse events come from java.awt.components. The component class is implemented by buttons, checkboxes, frames, scroll bars, panels, panes, content panes, a whole variety of AWT ecosystem items that you can encounter. So you can check on a checkbox because it receives a mouse event. You can click on a button because it too receives a mouse event. In order to make something receive the mouse event, like for example a wheel motion, which, you know, a lot of times a mouse has a mouse wheel. If you want to know where the mouse event is going, that component has to get focus. Getting focus is something that you can tell a component to do programmatically. You do not have to click on a component in order to give it focus. However, it must have focus to receive the events. That is true whether they are keyboard events or mouse events. So, if you want, for example, the keyboard to have its characters appear in a text field, you can traverse the focus tree into the text field by either clicking on the text field or by using a tab. A lot of times if people hit tab, it traverses from one text field to the next, and you can control how focus traverses. That's probably more information than you needed, but you should know it. You are not always going to be getting those mouse events unless you're listening to them. So that means you have to add the mouse event listener, and you have to get focus. So, the mouse is special. Why? Because there are these listeners that listen to the mouse events, and you have to implement them, and then you have to add the mouse events to the component. So you have to add the mouse listener. You have to add the mouse events generator to the mouse listener. And their mouse listener is going to listen for mouse pressed, mouse released, mouse entered, which means the mouse has arrived into the field of the content pane, mouse exited, which means the mouse has left the content pane, and mouse clicked, which means that you have pressed and then quickly released the mouse. So those are all different mouse actions. And you may have, in your Pong game, only to care about mouse clicked, because mouse clicked will start the ball. Right? The ball just sits there in the field. Mouse clicked makes the ball go. Then you will need to use the mouse motion listener, which generates an event every time the mouse is in the field of view, that is, mouse is entered and has moved. So those mouse motions are used in order to move the paddle, you see. So you need a mouse motion listener and you need a mouse listener. The mouse motion listener is used for when you move the paddle. The mouse listener is used for when you do a mouse clicked, and that enables you to launch your ball and start the game. If you hold the mouse and then move it, that's called a mouse dragged, and you probably won't be using that for your game. So, let's have a look at some of these. No, that was it. I was going to do a demo. I thought it would be a little easier to show the mouse motion handler in action than to have a bunch of static slides. So now what we see here is a component called the closable frame. And the closable frame is nothing more than a frame which allows you to close. If you didn't have a closable frame, it wouldn't dispose of itself and shut itself down if you hit the close button. So what I did was I created my own little closable frame, which is nothing more than a frame that allows you to become invisible and dispose of the frame when you click the close button. And you can try the closable frame right now. It implements a listener called a window listener. It has a thing called the close adapter, which disposes of the frame and basically releases the storage needed to create the frame. The mouse me example has this closable frame in it, and what it does is it has its own little mouse motion listener and then mouse listener. Remember, the mouse motion listener is going to generate an event every time you move the mouse, whereas the mouse listener is going to generate an event if you click or press or release the mouse. To see how track mouse motion works, you can see the mouse motion listener. Here's the interface. It requires mouse dragged and mouse moved be implemented. You provide that implementation as an inversion of control design pattern. it's called back for you whenever those mouse motions occur. So then here's your mouse dragged. Now remember, mouse dragged occurs when you hold the mouse button down and then move the mouse. But we don't care about mouse dragged for this particular application. We only care about mouse moved. So what I did for mouse moved is I went to the mouse event, and now you can see how you might populate a data structure that might be transmittable across the network. And this data structure might have something like the location of the mouse, or some point. It's a two-dimensional point. Point is a data structure stored, it's a class, which comes from java.awt.point, and stores an x coordinate and a y coordinate, and that's it. That's all it does. So when you do p.getx and p.gety, or even, I think p.x, that's an int. So you could just say p.x right in here. Because why? Because points in the screen coordinate system used by AWT by default are pixel coordinates, and pixel coordinates are always integers. Right? You don't have floating point coordinates for this particular application unless you go through some kind of scaling. And you're not going to be scaling. You'll be working in screen coordinates. So you can just say p.x, p.y. And what does he do when the mouse moved? Well, he just sets the location. He doesn't actually do anything. He could probably print the location. I suppose. S out, Control J, Enter, P. So then you could output a series of, quote, mouse moved events, end quote, plus, and output the two-string representation of the point data structure to the console. Right? So what that'll do is it'll output x equals whatever, y equals whatever. So now if you run this program, it should create a closable frame with a track mouse motion listener that outputs onto the console, in theory. I could be wrong about that. Okay, I better look at this program before I make claims about how it works. Where is closable frame being used? So here's closable frame. There's the mouse listener. It's called mouse me. Where's mouse me? Mouse me is not the same. I mean, here's closable listener. That's good. Track mouse motion listener. Add mouse motion. I don't see where I've added the track mouse motion listener to my my closable frame. So let's go to the closable frame. Get content pane. Add mouse motion listener. New track motion listener. I got new in here. Now what's his problem? He can't resolve the track mouse motion. I thought we just saw that. Oh, because it's a nested reference data type. No, it isn't. Is it? Track mouse motion listener. Yes, it is. It's private. I think I can make it public. And I think I can move it to, what's his problem now? Move it to, he wants an outer class. Huh! He's being difficult. I'll just add my own mouse motion listener to this. I wonder if I should start from scratch on this. I got weirded out with this supposedly simple example. What does this mouse motion listener do for me? New motion mouse listener. Motion mouse listener, mouse dragged. He does system out.println. He should be working. Closable frame we already saw. Mouse me, I got that already. Math utils, I don't know why that's open. Closest pair, I don't care. CPP, don't care. Morph utils, don't care. I lost my place. Shoot. I may just start something from scratch because I'm a little weirded out by this example. Let's do a new one. New Java class. I'll call it mouse example. And for my mouse example, I'll make up a main method. I'll put up a closable frame, JFrame, equals new closable frame, and Alt-Enter to import what I need. I'm going to set the frame size to be 200 by 200. Then I'm going to do set visible to be true. And I just want to show the frame. That's all I want to do. So that's clear. Everybody's good with that, right? Every time I think something is trivial, it shows me how wrong I can be. Okay, so that's working. So now what I want to do is I want to go to the closable frame, and I want to add a mouse motion listener. And I'll say new mouse motion listener. Boy, you know, I hate these trackpads. Is there some way to disable them? Mouse motion listener. And now here's mouse dragged and mouse moved. Let's try mouse moved and print out the mouse events.
So
S out, Control J, Enter, E. Yes, sir.
you would just leave mouse drag alone.
Well, I'm not dragging the mouse this time.
But so that's fine to leave it.
Yeah, you don't have to
It, but it
implement.
doesn't do anything.
My implementation does nothing,
And that's fine.
and that's okay.
Okay.
Here I'm just going to print something every time the mouse is moved. I want to make sure the mouse events are connected to the closable JFrame. So let's see if this works. And they are. So now you can sort of see the every time that I move the mouse, we get a series of mouse moved events. So now what I can do is I can go into mouse event E and get the point. And presumably I can print the point. S out, Control J, Enter. Let's print the point. And let's see what that buys me. And I'll comment out the event. This is a much easier way to do the demo starting from scratch, because now I know exactly what's on there. And that's working. So now you can see the point's X and Y location. And it's always an integer because it's in screen coordinates. If I were to stretch this out a bit, you could see much larger coordinates coming out. So everybody's good with that, right? Okay. Yes, sir.
Well, does it make a difference if we use get home versus just get X or get Y separately? Or?
You can certainly do that. Let's see now. E dot get X plus E, oh I know, plus quote, comma, end quote, plus E dot get Y, and let's see if that works.
Yeah, I'm assuming for the project we would only end up using get Y probably anyway.
That's true. That's a good point. So there it is, X and Y. And you might like to know when somebody clicks so you can start. Now for clicking, you would want to do a different kind of listener. What kind of listener do you need? Yes, sir.
I'm still confused what's the purpose of the listener. It's going to listen what is going to happen.
Yeah, so if you look at the mouse motion listener, what you see is something that has a very simple set of methods which are acting as a specification. When a mouse is dragged, the mouse dragged method is called. When the mouse is moved, the mouse moved method is called. And what you want to do is you want to intercept those events in order to do some kind of action or processing. So you supply an implementation of the mouse motion listener interface to the component that generates mouse events. And when those events are generated, you get a callback. And that callback is what I meant when I said we have an inversion of control. So that inversion of control means you're supplying methods that are invoked for you by the component. And you have to know what to do in order to be able to process those events properly. And so this tells the computer program what to do in order to process the events properly. Only thing it's doing here is printing. That's how you deal with moving the mouse. There's other things that can happen. For example, this closable frame, you could add a mouse listener. Okay, so here's the mouse listener. Now the mouse listener has to be supplied with some implementation of the specification called new mouse listener. Alright, so the mouse listener specification requires listener listener. Right? And now he wants to implement. Where's the? He should offer to implement the methods. Import the class, mouse listener, and then implement the methods. And now look at all the methods you have to implement. Mouse clicked, mouse pressed, mouse released, mouse entered, and mouse exited. So these will all be implemented with null bodies for you, and then you can override the implementation, thus providing a way to satisfy the mouse listener specification. So having done that, if the mouse is clicked, you can say S out, Control J, enter, quote, I have been clicked. So now you can detect.
That's the only one that's relevant to our game.
And that's the only one you care about for the final.
Okay.
So now we have two listeners going. One is called the mouse listener, and the other is called the mouse motion listener. The mouse listener will tell you when you've been clicked, which means you can start the game. The mouse motion listener will tell you when the mouse has been moved, in which case you can move your paddle. Got that? Okay. So let's run it and see if it works. You can also add a mouse wheel listener, and you could use the wheel for moving the paddle, actually. That might not be a bad idea, come to think of it. But not every mouse has a paddle, right? If you have a trackpad on a Mac, you might not have a mouse wheel. So now here's the mouse moving. Let's try click. It says I've been clicked. Click, click, click. Click, click, click. Move. Click, click, click. Move. Click, 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 click. Got that? Click. Click, click. Click, click. So now you have, what is it? Some reading, right? We did some reading about events. You got the little mini PowerPoint lecture, just enough to know what you need for your final. You got the little demo, shows you how to deal with the mouse moved and the mouse clicked, the only two things you care about for the final. So they have some urgency or immediacy. That's why I kind of skipped over the whole big, humongous PowerPoint presentation. And the only other thing you're missing now is the keyboard. So now you know everything you need to know about the mouse.
I have a question.
Yes, sir.
So all this makes sense, but in the context of like a larger RMI program, like where does this fit in?
Great. So now the question is, what do I need in order to make my my program work using RMI? That's a really good question, but it is not directly related to how do I use the mouse, which is a different question. So if I was going to use RMI, I would communicate to the client or server using the most compact data structure I could find. So if somebody said, well, in my Pong game, the only thing I need is the y coordinate, I don't need the x coordinate, then the only thing you need in your data structure is y, integer y. If in the Pong game you said the only thing I need is to know if somebody clicks in order to know when the ball should be started, then the only thing I need is a Boolean that says I've been clicked. So now I'm looking at a class, which I will call a data structure, which contains an instance variable. The member will be y, the y coordinate, and the other member will be a Boolean that says I've been clicked, and it will be true or false. And that's it. But there's another one, right, and it's related to the keyboard. And the keyboard was going to use a character, and the character was going to be R, and R would cause the game to restart. So I've got now three things that I'll be transmitting: a character, a Boolean, and a y coordinate. And there was another thing that people wanted to do, and that was the indication that the enemy score was important. So we'd like that score, if it changes, to be transmitted. And the score for the enemy is like an integer. We could call it score if you like. So now I've got four things I need. I've got the score, the y coordinate, a Boolean that says I've been clicked, and something else I forgot. You guys taking notes?
Score.
I got the score, I got the y coordinate.
The R.
Oh, right, and the character, R. The thing I've been clicked, and the character R. I should probably write this down, right? So things you might need, right? Things you might need. You might XMIT for a Pong game are the score, the y coordinate, help me out here. I've been clicked. A Boolean is clicked, and a character. And that's it. That's all I could think of at the moment. Right? So if you're thinking about it, you're really dealing with the score, which is an int, the y-coordinate's another int, is-click's a boolean, and a char, which is like a 16-bit quantity, unsigned. And the whole thing has to be put into a class which is implementing serializable and then can be passed across the network with some kind of a callback. And we can do that. But first thing I want to do before I do that is review the events for the keyboard. So if you can hold your suspense on how you'll transmit this data structure, we'll do the keyboard next. How's that? Okay, everybody good? All right. So, no questions? Some questions? No questions. Moving right along then. Okay. So one of the things that I have prepared is way too many PowerPoint slides, and I only want to focus on that stuff which I think might be important to you. So let's just look at a really short thing about keyboard events. And so what I'll do is I'm going to show you the 5 PowerPoint slides you need in order to deal with keyboard events, and that's it for the final. And then we'll do an example. We'll work the example from scratch. From scratch. Now, what I've done here is I've broken it down into 3 different areas. One is key events, the other is keyboard acceleration, and the third is text fields. Of those 3 areas, the only thing you need is keyboard events. That is the only thing you need for the final. Okay? I'll tell you right now, if we get involved with a discussion about keyboard acceleration, it's control characters and their equivalents with menu items. And text fields, well, you know what they are. So let's skip that part. We'll just do the key events. So just like mouse events, key events require a Java component that obtains focus, wants a key listener, and then takes that key event and passes it to the key listener, which means it's another example of inversion of control where callback methods are used. When the key is pressed and the component has focus, that is, it's selected, then the key event will flow into the component and into the key listener. 2 kinds of components that I know about. 3 kinds of components that I know about. AWT components, swing components, and SWT components. SWT, that's a standard widget toolkit which comes with Eclipse. Not particularly popular, but it's used. There's a couple key events I care about: key pressed, key released, and then there's meta keys, Alt, Control, and Shift. Well, if all I care about is whether or not a key is pressed, right, that's a key event. Somebody might hit R, and then I restart the computer. But if you want a key released, I mean, you could do it when the key comes up instead of when the key goes down. So it doesn't really matter. Keyboard controllers implement key listeners. Key listeners have callbacks for key typed, key pressed, and key released. In fact, what you could do is key typed. You can intercept any character, and so if somebody types an R, key typed will be invoked, and you can implement the key typed, print out the key event, and you'll see the key that has been typed. Got that?
What's the difference between typed and pressed?
Pressed means it's held.
Typed is just like...
Typed means it's pressed and then released. And then released just means it's been released. It might be very good to use key pressed because you can combine that with meta characters like Control, Alt, Moth on the Mac, Command, I think they call it, or Option. You know, you can do all kinds of interesting and wonderful things if you're going to intercept key pressed.
Question.
Yes.
For our game, when we press the key, it's going to just like wipe everything back to the initial state, not actually start the game. It's going to
reset.
Wait for another click to
Yeah. So you hit R, the game resets, then you hit click with the mouse, and the game will start.
Okay.
So R just does a reset. Got that? So I'd like to intercept key typed. So I've got a keyboard package already, but I'm going to implement something from scratch, and let's see if we can do that. So that's my whole shebang. Everything you need to know is key typed. So let's go back to our closable J frame, and let's add cf.add, and let's see if we find a key listener. So here's key listener, and we'll put in a new key listener. And we'll give it the, what's his problem? Import the class, and now what's he need to do? Implement the methods, and here's where you go. And they'll come in automatically as null-bodied implementations of the key listener interface. Null-bodied meaning they won't do anything, and you'll have to provide an implementation. And so here comes key typed. That's the one we cared about. I'm going to take this key typed and I'm going to print out the key event. S out, Control J, Enter, E. And now what we'll do is rerun our program. And now you have two different input devices being handled by the menu, by the window that you're creating. The first is the mouse, which we already looked at, which, by the way, is identical to the trackpad. You know, you can use the trackpad and the mouse interchangeably as PIC devices. Or, what's the other one? The keyboard. So let's start by getting mouse focus. And you can see mouse events are coming in. Click events are here. Let's try and generate a keyboard event. I'm going to type the R key. And there it is. Key event typed. Key code 0. Key character R. Here's key character Q, W-E-R-T-Y. Key character's off to the side. I don't know if you can see it. Let's take the key character and print it out so that we can respond to it. So E.get key character returns a char. And if, I guess we could just print the key character. S out, Control J, Enter. Let's print out the key character. That sounds like a very fine thing. What do you think? So far, so good? So apparently I don't need to move the mouse at all. I can get characters through here. This is a test of the chars flowing through the event system. Got that? Now if you want to just detect one character, you could say something like this. If getKeyChar dot equals, equals because it's a primitive data type, quote R, end quote, end paren, then S out, Control J, Enter, quote, reset. What do you think of that? It's not working. Oh, it's one of those you got to be patient things. R is for reset. None of the other stuff comes through and does anything except for reset. Reset. Got that? So now we've got character. Oh, let's do the mouse. Here's the mouse. I'm going to do the trackpad. There's the trackpad. Right? Java doesn't know that I'm using a trackpad. Java cannot tell that I'm using a trackpad. Trackpad and the mouse look the same because they go through the same abstract hardware layer in the operating system. Yes, sir.
On a Mac with 2 fingers scrolling, make Java think it's a wheel.
We didn't do the wheel listener, but yes, I think on a Mac you can emulate the wheel.
You can scroll with 2 fingers.
Yeah,
so
you know,
it's a wheel.
I never use a trackpad, so someone told me I had to use 2 fingers. Maybe it was you, but I never learned that gesture because I never bothered with trackpads before. I always threw a mouse on all my laptops. So that's probably a standard thing, right? 2 fingers.
Yeah,
It's
that's pretty basic.
basic.
Yeah.
So that's me, Mr. Dull Skill Set. I had no idea. So everybody knows that but me. I sit there and I go on it with the trackpad and I go, how do people use this thing? I try and double click on a trackpad like this. That doesn't work. How do you double click on a trackpad? You can? So if I wanted to go over here and I go double click, oh, that works?
Sometimes there's branches that they display usually work.
Oh, okay. Yeah, I don't know how to do basic things like clicking.
There's like tap to click and there's like click to click.
Well, I have other skills. I know how to punch cards and write Fortran programs. So, yeah, I have obsolete dinosaur-y skills. I can read paper tape. Useless skills. So there you have it. I've gotten you past all the event stuff you need. That's it. Good, right? I don't hear this exuding confidence from you, Kyle. I guess, whatever. Okay. So then, to backtrack to your prior question, which was not directly related to events, how do I transmit all this good stuff across the network using RMI? Right now, I had to postpone your question because moving through to the RMI part basically adds a whole layer of complexity to the discussion. I wanted to get back to the RMI Hello server and the RMI Hello client. But, look at the time. It's already 3:05. So I thought what I would do is take a logical break. We're done with events. We're done with the mouse. We're done with the keyboard. And the next step is to try and encode a basic data structure and transmit it across the RMI substrate in order to be able to get our little programs to communicate on the network. So let's take a break and then come back in like 5 minutes, if that's cool. Thanks.